Yeah. Is this for him or for Watkins? Okay. Because I owe Watkins 100. Well, I stole all of his yesterday, so take those over. Yep. All right, here we go. You don't need to lock it, Chris. All right, so what did we get for our answer? And if we are all fine, then we won't work on it. Oh, you've had so long to wake up. So we end up with C what? 10. Who agrees? Raise your hand. C10. Okay. Keep going, Hermes. H20. Whoops, why'd I put, oh, because, see what happens when you teach chemistry too long? I meant to do that. And O what? C10H20O. Nobody agrees? Okay, what did everyone else think?
I got something.
What'd you get?
Like, we got the same numbers, but then we started dividing it. It ended up different. I did a different thing. I rounded it up.
All right, well, should we ask Siri? Actually, I can't. Should we Google it? Menthol. Yep, C10H20O. They win. C10H20O. 40 minutes. Ooh. I didn't want to spend much time, but I better. Who had that answer? Just 2 people? Okay, so we must be working through this together, right? Gosh darn people. Okay. So we may have gotten bitten by the rounding masses. Most likely we did. Because things really do matter quite a bit. All right, so it's composed of that. We get 0.2829 grams of CO2, correct? And we're going to do a picket fence, which after this example, we're not going to do picket fence anymore. And then after we do that, we're going to go back to doing picket fences forever. Yep, I'm a genius. 44 grams CO2 for every 1 mole CO2. Everyone had this right anyway, right? 1 mole CO2 per every 1 mole C. Then we have 1 mole C, 12 grams. All right. And what did we get? Did everyone get the same answer there? 0.08?
I got 0.077.
0.077?
Yep.
Okay. Now, did anyone write the little thing right here?
I did.
What'd you get?
0.306.
What's the red number for? Moles. Correct. Uh-oh. Am I really not? Oh, I really am. All right. So far we're kind of all right. Then my water. That's this divided by 44. And it's just to save me, because I'm going to need that number in the future. That's the number I'm going to divide by. Oh, well, maybe. It's the number I'm going to use when I divide by others by the smallest number. All right, 0.1159. And that's grams H2O. I'm annoyed that I did that in color, but whatever. 18 grams H2O. I'll scroll. You're probably annoyed because you can't see. 1 mole H2O. We have 1 mole H2O for every 2 moles H. For every 1 mole H, I have 1 gram of H, and that equals what value? Point oh what?
12.013. Did that right too.
All right. And then hydrogen's nice because it's the same value, right? Yep. 0.013. That's looking hopeful because those are almost half-Cs, right? We'll see. We'll see. Still got oxygen to deal with. All right. So to find oxygen, I take my initial 0.1105. 1005, right? Sorry. That's my initial. I take that and I minus the sum of the other two. And I should get a number. 0.0 what? 0.0015. 0.0015?
Your carbon is, you just wrote your carbon wrong.
Oh, I wrote the moles. I did that second hour yesterday too. But the answer will be this?
Yeah.
Okay, I apologize. I subtracted the moles instead of the grams.
What the?
It was this. I wrote that number on accident.
Oh, never mind. Yeah, I did that right. Okay.
And is that 0.0?
Yeah, I did it right then. Yeah, I got that's right. 0.005.
That's a gram value. So you divide by. I didn't get that.
Okay, yeah. Everyone here in Hitchin, that's in grams. So what do I need to do to that number? I get to change it to moles by dividing by the mass of an oxygen. And I get what number when you do this?
0.00066.
2066?
3 zeros.
Zeros. Wow. 66. All right, so here we go. This isn't going to be super hard. You can do this math in your head, honestly. And you're like, what? Remember, they're most likely going to equal whole numbers. So this one up here, that's going to be some easy-ish math. Anyway, so we got 0.0066, 0.00066. That's 1. Okay, so my oxygen is going to have a 1 subscript. Over here, 0.00066. That's probably, no, and I know the answer, but that's going to be 20. Okay? And 0.00066, that's going to be pretty much 10, right? So C10, H20, O. Yeah.
So wouldn't the molar value of H2O, wouldn't it be 12 not 13 because 0.013 divided by 0.0006 is 21.5.
Okay, probably, but here's what's getting us in trouble. And this really, in combustion, it really is extremely important. We haven't got caught on it until now. But the molar mass of carbon dioxide is not 44. It is 12.011 plus 15.994 times 2. If we use their exact masses, then we would have been really, really, really close. So we've been rounding for time convenience. But if you're dealing with a really small mass to begin with, you probably should use a more exact mass from the periodic table. Yeah?
So how did you go from like oxygen being 10 to having C10H20O?
Oxygen wasn't,
I got 9.9.
oxygen wasn't 10.
Because I got 10 for oxygen, right?
I didn't get that 0.0105.
No.
You have to retimes them all together.
What?
I think what I did is I did the empirical formula for carbon and hydrogen before I got oxygen. So if you need to get oxygen, so you times it by oxygen, it's the lowest number.
Yeah, oxygen was the lowest number. So if you went out of order, you were in a lot of trouble already. All right, I'm not positive that that went perfect. Do we say C10, right? H20O. Woo. All right, I want to give you a shortcut. If you don't like the shortcut, don't take it. All right, on my mission, shortcuts were banned because we lived in Virginia where there's trees everywhere. And people, they're like, well, just take that shortcut through the woods. You would get lost. You would be going from here literally to the scorer's booth, and you would get lost. And the shortcut ended up being the long cut. We were never allowed to take the shortcut. The trees were just super thick there. So if the shortcut makes you get lost, then don't use it. But here you go. Can somebody tell me real quick what 12/44 is? Or 6/22, or 3/11. 0.27. So 0.2727. All right. Can we just call it 0.273? You okay with that?
Yeah.
Okay. What I just did is I eliminated the picket fence. This is a number, if you like this, that you should memorize. All right? So what that number does, it gets rid of all of that. So stick with me. Follow my logic. Excuse me. When we find the mass of carbon from carbon dioxide, every single part of this is always the same, right? What's the only difference? It's your initial mass. So if you would like to save yourself some time, and put this in your notes if you want to, you just multiply the initial mass of carbon dioxide by 0.213.
But then you still have to divide by the moles later.
Yeah, after that you'd have to divide by 12. Now, like I said, if you don't like this way, then don't do it. It's fine with me. Something is lighting up. Well, yeah. We wouldn't.
You would times it by C, dividing it by, well, not C, but you times it by that weird number instead of.
Well, that number is the answer to this divided by that. So we are multiplying it by 0.273. What did you say? Oh.
So 12Gc is the atomic mass of carbon.
Right. But we.
12G or 44G CO2 is the atomic mass of carbon.
Yeah, like a little bit tricky. We would call this the atomic mass. It's not an atom, but sure enough. I'll usually call it the molar mass.
Okay.
Same exact idea. Just one means for the atom, one means for the molecule. All right. So the same idea works for hydrogen, but if you listen to Emily, she said, well, you got to get this anyway. And that's a true fact. So if you do the shortcut, that'll get you your grams. Do remember that these have to be divided by 12. Same with hydrogen, but it's going to be easy because it's just ones. So hydrogen, to find that from water, you just multiply it by 1 divided by 9. Isn't that 0.111 forever? Double check me. It's been a year. All right. 3 decimal places should be plenty. Now that one, sure, you have to convert it back to moles, but that's divided by 1. I can do that all day long. Okay? So we can really eliminate these 2 picket fences and speed up the process if we want to.
So after the shortcut, you still convert it to moles, right?
Yep, you'd be left in grams. But what we were saying about hydrogen is to do that, we have to divide it by 1, so the math is the same. All right. Why did we have to get the grams if we really need moles anyway? To get to oxygen. We can't do the same math with oxygen because it came from more than one place. Okay? I don't know if I have one more, but we might need to. Did we do this yesterday? Okay, we better do it. I didn't plan on it, but we kind of sucked on that last one, right? this is cut out from somewhere on the internet, so it might look weird, but what? Trioctane? There is oxygen in it. It has been brought to my attention by multiple people that some of my videos don't load anymore, and I cannot seem to get them at all. So if it says that the Echo community is now closed, those are gone. I will start to try to make more on my prep hour, but they took forever to make. I'm a little bit annoyed. Oh, don't fall for what I just fell for. Every single problem we've done listed carbon first and water second. This one doesn't. Well, you're finding the empirical formula, and then if it matches, then you're done. But if not, then yeah, you find the molecular mass. Oh, this one's easy, isn't it? Okay, who has the answer? Who still's working? Is anyone still lost?
I accidentally went through the woods and I got
You mock me, but the woods are so thick, and this is a graphic story to put on a recording, but whatever. I moved to an apartment in March. I was there for 9 months. And you're going to be like, what? So anyway, it was in the middle of what's called a holler, which is just a teeny little canyon with trees everywhere. And it had a deck out the back. And every morning I woke up, I just went and peed off the back deck because I could, because it's America. Are we all right with that? Okay. Well, along comes November and December where fall hits and the leaves fall, and there is a house about from here to Miller's door behind that apartment that I never knew was there. And there,
Scarred.
no, there's no way they knew I was there. They had no idea I was there, hopefully. Yeah, anyway, you're welcome, internet viewer. All right, I did this the short way, or the fast way, and I got C3H6O3. Does anyone agree with me? Raise your hand. Almost? The empirical was CH2O again. And you're like, oh, why does he always make me do sugar? Well, it isn't sugar this time. It's trioxane. Any idea where the tri comes from? There's 3 C's, and the oxane just comes from it being C3O3. All right. What I mean by the short way is I did 25.612 times 0.273. That's 3, with the 7 in the middle of them. And I got a value of 6.99. Then I took the other one, 10.477, and I multiplied it by 0.111, and I got 1.164. Is that right? And then I added those together, and I got something I never wrote down. Yeah, I never wrote it down, but I subtracted this answer from 17.471 because my initial mass minus what I already know will tell me my mass of oxygen, and my answer ended up being 9.31. Sound good? To each of these, I then had to divide by their molar mass. 12, 1, 16. Does everyone know where I got 12, 1, and 16? Raise your hands if you know where I got 12, 1, and 16. Okay. Tell Brittany where I got 12, 1, and 16. All right. That gave me 3 numbers. And I'm going to put this equal sign up here. You all right with that? So I ended up with numbers I never wrote down. Was this 0.58? It had to be, right? This is 1.164, and this was 0.58. Divide by 0.58, that's a 1. 0.58, that's a 1. 0.58, that's a 2. So I had CH2O, but that only adds to 30. It should add to 90. So how do you make it work? Multiply it by 3, so C3H6O3. Hadley, I'm worried about you. Are you super with me or super gave up on me? Half C's. Do you watch my videos?
Last night I did not get home till like forever because I had
Will you watch my videos?
because I did not work today.
Okay, I'm committing you to watching them. The one from yesterday, you were here yesterday though. Okay. All right. All right. We're changing gears now. We're doing what we are going to call stoichiometry. Who's super pumped?
Let's do another one.
No, we don't have time to do another one. There's plenty in your homework. All right. All right, don't worry about that part yet.
Worry about this part right here.
That's I looked at these in the notes. I don't know where that came from.
Really?
Yeah, it's a combustion one. It's probably from your homework. Someone probably asked me for a problem from your homework. So I would bet in your homework there's one that is C2H6O. I don't know. There was no sentence previous to let me know what this was from. All right. Every time I spell stoichiometry, I probably spell it differently. Are we over that? Okay. Like the word yield, I got a 50-50 shot that I put IE or EI. It happens. I before E. Y-I-E-L-D. All right. If you never would, but if you read Stephen Thompson's paper, he described chemistry as the perfect mix between English with stupid rules and math. So math where things mostly work most of the time, but not unless you're always wrong or whatever Brian Regan is. I before E except after seeing any time that you think like it. Yeah, there you go. All right, so here we go. Stoichiometry is based on, you don't need to write, but if you do, it's fine. The law of conservation of matter.
What's the B word?
Based. I know, it looks good.
Careful not to drop it.
I will not. So here we go. All I like to do it, we're just going to do it. Are you ready? So for instance, I have copper plus chlorine goes to copper 1. No, we'll say copper 2 chloride. No. Yeah. We'll just say CuCl. So that's copper 1 chloride. Okay. So stoichiometry, first off, requires you to write and balance an equation, which we worked on, right? We've worked on that a lot. Okay. Is this balanced? No, I was going to make it balanced for you, then I thought, well, that won't help us learn. I need to put a 2 right here, right? And a 2 right here, and a 1 right there. Okay.
Dude, I can't believe I balanced that first try.
You.
That's easy.
Well, hey.
I got troubles with that.
That's like cutting the little kid's balloon and watching it go up and laughing at him. He was feeling so good. And you're like, forget you guys.
I might as well drop out now
Yep.
because y'all are making fun of me.
Hey, Tyler, just think, you could have done that 3 weeks ago. You're so impressive.
I know, right?
I'm impressed. Okay, here we go.
I was impressed.
I'm impressed too.
This is what stoichiometry is. It'll say if you have 30 grams of copper, how many grams of CuCl can you make? That is a stoichiometry problem. I give you a reaction, usually in words. You have to write the reaction, balance the reaction, and then I ask for you to do some solving from one thing or to another. Okay, we are going to follow the same pattern over and over. And don't write it down, but you're going to go from grams of one thing to moles of that thing to moles of the thing you want to grams of the thing you want. Now to do that, we're going to put it in a picket fence just because it's a nice organizing technique and helps us not screw up. So I'm going to put a line right here, and then I'm going to scan up, and here we go. So what you do when you do these stoichiometry problems is you always start in the top left with your given. All right? Now, kids that already had chem, they're going to feel really good about this pretty fast. So what number and unit did I give you?
30 grams of CU.
30 grams of Cu. Now, the next thing you would do is you would come over here, and we are going to solve for, what did it ask for? All right, grams of CuCl. All right, now, this whole concept is based on the fact that whatever's up here, the unit always goes right down there. So, what unit is right here? Grams of Cu. So I'm going to put grams of Cu. Now, this whole thing right here, I find from the periodic table. So how many grams of Cu are there? That's the one we round to the middle. 63.5. You can put 5.4, that's fine. All right, and anytime we write something from the periodic table, it's its mass per what? All right, 1 mole of the same thing. Make sure, like red alert, do not ever have a different mole and a gram. The gram and mole is always the same element. Okay? Don't ever screw that up. All right, now, remember, the picket fence is based on the fact that whatever unit is here goes down there. So, what unit is down here? Mole of Cu. All right, now, I need to come up. This one I find in my balanced reaction. I don't know, balanced reaction. So I scroll up. What is in front of Cu? Just the Cu. A 2. So I'm going to put a 2 moles of Cu. And what I'm doing here is I'm going from moles of what I was given to moles of what I want. This is the key. So what moles do I want? CuCl. All right, and what's in front of that? There was also a 2. So this step might seem meaningless, but I promise you it is not, because it is not always the same number. What comes down here? All right, moles, CuCl. What must be on top? Grams CuCl. I already wrote that. That's the answer, but I'll just leave it there. That's convenient. All right. Now, I want grams of CuCl in my answer, right? So that means all my proportions are lined up, and I'm ready to just do math. So you do need to know, what's the mass of copper 1 chloride? 99? 5? It's got to be a 5. Oh, no, wait. Chlorine's a 5 also. Sorry. Well, I doubted you. I should never do that. I remember from last year. All right, I have 99 grams. Copper chloride on the wall. 99 grams of copper chloride. Hey. No, I'm not a singer. All right, here we go. I could do some stuff before I do some stuff. Math-wise, what numbers do I not need to put in my calculator? Both the 2's can cancel out. Whoops, I never put a 1 here, but there was a 1, right? Sorry. The mass is always per 1 mole. Okay, so now I'm ready. I don't need to type 1's in. So this is how you do these problems. You take 30 and multiply it by any number on top. So 30 times 99. And then you take that answer and divide it by 63.5. Now, multiply all the top, multiply all the bottom, and divide your 2 answers. If you do math on your phone, it's really, really good at screwing you up, because you're really, really good at screwing up. I have a 46.77. Who agrees? All right, we have 40, I already forgot. 46.77 grams of CuCl2 can come from this many grams of copper. Now, there is an assumption in this sentence. Do you know what this assumption is? The assumption is you have plenty of this. Did it say anything about chlorine gas? No. If it says nothing about the other reactant, you assume it's an unlimited amount. Okay? Which is implying that copper is what we call our limiting reactant. Okay? A limiting, I think it was right here. It means something runs out and the reaction stops. The limiting reactant is going to be extremely important, even though we never talked about it last year. Go ahead.
What unit is that? 46.7
grams of CuCl.
Will we ever get a question that puts a limit on both and we have to
Yep.
solve it for both?
Yep.
and do the lower one?
Did you hear that? He asked, is there ever going to be a question where it gives you both and you have to calculate both and you have to pick the lower one? Absolutely. From now on, almost every question will be like that. So it would say you have 30 grams of this, 40 grams of this. How many grams of that can you make? Well, we're going to teach how to do that it takes time, okay? These aren't hard, but you got to invest some time. All right.
Are you learning shortcuts for these?
No. Like,
I mean, ideally, can we use
kind of.
the same shortcut?
Well, no, because we're, like, ideally, sure, if you knew the ratio for every single combination on the periodic table, but that'd take too much time. All right. Here's the real truth. Look, it's not as hard as you probably think it is. 30 grams of that is roughly half a mole, because the mass of that is roughly 60, right? 40 grams of that is a little bit more than half a mole. Now, I knew that because this is 71, 47, 4/7 is over half. So you convert them to moles and see which one's smaller, then you move on. But we actually teach you a little bit different way. But conceptually, it's not really as hard as you might think it's going to be. All right. To give you an example of a limiting reactant, if we're going to make bikes, and I have 60 wheels and 50 frames and whatever else needed the rest, we don't care about that. But if I have 60 wheels and 50 frames, I can only make 30 bikes. That's easy enough, because it takes twice as many wheels, or our example would be twice the amount of moles of this as it would that. All right, so we would have what we call the limiting reactant, meaning when we ran out of wheels, we cannot make bikes anymore. And we would have what we call an excess reactant, which is the thing that's left over. So how many frames would be left over? 20. And all you did to find that is you took what you made and subtracted it from what you had. Okay? Everything we do with a limiting reactant problem is exactly the same as that. It's just going to seem a lot more complicated because we're not making bikes. We're making stuff with really long formulas. All right? If we were to write out the formula for this reaction, 2 wheels plus 1 frame goes to frame wheel 2. Can you kind of get that thing? So that wouldn't have worked, so that's why, like, it originally would have just been that. That is dumb. Wheel plus frame goes to wheel plus 2, or sorry, frame plus 2 wheels. That's where this came from. We had to balance it. Remember, 0 because it was our limiting reactant, 20 because it was our excess, 30 because 60 wheels can make 30 bikes. Here we go. Let's clear all this out. All right. Given 28 grams of sodium and 52 grams of Cl, how many grams of NaCl can you make? What is limiting, what is excess, and how much is left over of the excess? Oh, fine. My fault. Do you want to do this on your own? Do you want me to do it with you? Whoa. Fine. Do it on your own. What's on? Oh, I don't know. I really don't know. I made it all up. And I never say it the same. Like every night I sing my daughter a song to bed, and it's never been the same song, I'm pretty sure. This is funny. So, yes, I'm distracting you. Get over it. So when I sing church songs at church, and I have like my daughter, she's like right here, whatever. She always snuggles in the 2 o'clock one because it's late and it's her nap time. But anyway, so I make up words. I don't sing because I'm holding her, and it's always a song about Carly Jane. because that's her name. Okay? So I just have her there, and whatever the tune is, I'm singing some song about Carly Jean. Okay. 3 weeks ago, donde está? There we go. I don't promise you that in my hurry I won't make a mistake. I will do my best. Did I do something wrong?
No, I just remember is 52 grams of Cl the same as 52 grams of CO2?
Yeah. Sorry. This is chlorine. Thank you. That was bad writing by me. You wondering why I did what I just did?
Okay, so there's the 2 moles of NaCl, right?
Yeah?
But you don't times it by 2? You don't times the top row by 2? Where did the 2 cancel?
Right below it?
Cl2? On the second one.
I did. Did I not multiply it by 2? Thought I did.
Wait.
The only reason you do it was
Okay, I have 1 minute to try and explain what I've done so far.
How do you know how much is excess though? You take the one.
We'll get there tomorrow. Okay.
We're good. I got the same number, I just got there a different way.
Okay, so what I've done so far, and this is what I recommend. I made 2 picket fences. And I picked the 2 different starting reactants to solve for the same product. Okay? Now, there was only one product in this equation, so it was actually easier. The one that produces a smaller value is the one that's the limiting reactant. So right now I've only solved two things. I know that Na equals the Lr, and I also know how much mass I have to start. To calculate how much is excess, we'll pick that up tomorrow because the bell rings in 4 seconds.
Yeah, I'm getting it a lot easier than
Yeah, Mr. Davis, I actually feel like I know